Okay, so what is code? Code is short for source code, and it is basically instructions for the computer in a language that it understands. Code is basically instructions. The Arduino workflow. So for the Arduino, you have a three-step process. This is how it works for coding and uploading and using an Arduino. First, you write code on the computer. Then you upload the code to the Arduino board, and then you watch the code execute on the Arduino. You write, upload, and execute. This implies that if you change the code, you must upload the new code. If the upload fails, if your uploading of code does not make it to the board, then your board will just run whatever code was already on there before you try to upload it. Okay. Code will always stay on your Arduino until you upload a new code onto it. So if you upload a code to your Arduino that tells it to blink every so amount of seconds, then your board will do that forever, or until you upload a new set of instructions onto it. What language does Arduino use? Arduino uses a variant of C. C is a high-level language that has been around since the 1970s. It's called C because it is the successor of B. C is a language that has descendants in C++, Java, other classes, or other languages that we teach in other classes here at CBA. So C is a high-level code. So what does that mean? Well, there's high-level and low-level code. High-level code is user-oriented, which means it's a lot easier for humans, or for us, to read or write with it. In high-level code, many simple single commands take multiple machine-level instructions to complete, meaning that if you wanted to get something done, usually a single line of code can accomplish one task. Whereas with low-level code is machine-oriented, and it's more difficult for a human to read or write with it. Usually has strange, unreadable context and commands, and instead of one command or one statement having one effect, it's usually small commands that add up to big effects. All right, so this is almost the same exact code as our first lab from Lab 1A. All right, and we're going to break down different parts of it. Right here, these are comments. Comments are ignored by the computer and ignored by the program. Right here, this is the setup function. Within the setup function, we have the function body, which is the area between the braces. And notice that at the end of this statement, there is a semicolon. Semicolons always appear at the end of statements. This is the loop function. The loop function also has a function body. The function body is the area between the braces. Comments. Comments are ignored by the computer. They're basically post-it notes from the programmer to the programmer's self or to other programmers. You can write a comment with this character right here, a / and asterisk, or you can write it at the end of a line of code using a / to designate the comment. I'll show you an example right now. Here's my window. One way I can write a comment is / asterisk, and I'll say comment, and I end it with a asterisk and /. I can also, let's say I write code right here, and I put a /. So this is a comment, and everything after the / is also a comment. Okay? So there are two ways to write comments. Delimiters. Delimiters are paired and nested code characters used for grouping. So delimiters are used for grouping. Examples of delimiters are braces for functions, quotes for strings, single quotes for characters, square brackets, angle brackets, parentheses, and those / asterisk delimiters that we were talking about before. They are used for grouping, and they are paired and nested. Paired means that there are two of them. Nested means that they open and close the opposite way. Okay, so this square bracket opens to the right, and then it closes to the left. That means it's nested. In this block of code right here, we can see that the loop function is defined or delimited by this upper brace and this lower brace. This for loop is delimited by this upper brace and this lower brace. If structure starts here, ends here, and the else structure starts here and ends here. It basically opens and closes. You're setting the boundaries. That's what delimiters do. They define the boundaries in code. The setup function. It is not called the void setup. Basically, what you need to know about the setup function is that instructions within the setup function are executed first and once. What do you put in the setup function? Anything that needs to happen once. So prep statements. So setting your pin modes, creating objects, anything that you need to set up before the code really executes is going to go in the setup function. So prep statements. Semicolon. We saw that at the end of every line there was a semicolon, but not every line. Okay? Not every line. Only statements. Okay? So all statements end with semicolons. Semicolon means it's the end of a statement, so therefore it is possible to put more than one statement on a line, even though you should not. Statements are basically instructions, and semicolons are like the period at the end of a sentence. The function body. Each function has a header. For example, the setup function has a header called void setup, and then there's going to be a brace. Okay, everything between the open brace and the closed brace is called the function body. Indenting. Indenting is not required, but it is recommended. All the white space that you use or don't use is all ignored. So one space doesn't matter. Okay, so indenting is really just for organization, for your mind, which you should absolutely use. As a rule of thumb, you should always indent after an open brace and unindent before the closed brace. The loop function. So since the setup function is run first and once, the loop function is run after the setup function and repeatedly. So the loop function runs after the setup function runs, and it is run over and over again. Now keep in mind, the loop function is not a loop. This is because loops are constructs within programs to make certain lines execute over and over again, which is a concept that we're going to cover in a later chapter. All you need to know is that the loop function is not a loop. But what do you put in the loop function? This is where you put basically the bulk of what goes in your program. So most of what you're going to code is going to go in the loop function. So most of your code will go there. This is because Arduino projects are usually things that do the same thing over and over again. So most of your coding is going to happen in the loop function. Keep in mind that each statement has an effect, especially in your loop function. Okay, statements are like actions. They make things happen. And statements always get a semicolon at the end of them. Within the function body, we call that the local space. So the area between the braces and the function body is called local space. So everything inside the setup function and the loop function is local space. Outside of the setup and loop function is called the global space. Okay, so you can write code outside of those constructs. However, most of what you're going to put out there is going to be creating and declaring variables, which we'll talk more about later. All right, so parts of the program. This right here, this is a group of comments. These comments are they in the global space or are they in the local space? They are in the global space because they are outside the setup and loop function. This block of code right here is the setup function. Everything within it is called the function body. This is the loop function. Everything within that is the function body. All right, the 3 building blocks of programming. There are 3 basic building blocks in programming, and all languages have these simple elementary constructs. Sequence, selection, and iteration, the 3 basic building blocks of programming. So sequence. Sequence means that lines of code are executed one by one from top to bottom within a code block, right? So the first line is executed, and then the second line is executed, and then the third line is executed, and so on. There is a sequence of lines that are executed. If you were to think about the code for a stoplight, the sequence for that would be that the light would turn green, then the light would turn yellow, and then the light would turn red. That is the sequence. Code block is any grouping of source code, usually found between braces. Selection. This selection is coding for decision making. If a program asks you a question saying, would you like to see a waterfall or a butterfly? And you have a choice, you could click waterfall and you'll see a waterfall. You can click butterfly and you see a butterfly. And this is because the code is written so that if the user clicks waterfall, show a waterfall. If the user clicks butterfly, show a butterfly. This is selection. Another example of selection is a thermostat. Let's say you had a thermostat and you programmed it. If temperature is below 72 degrees, turn the heat on. If the temperature is above 72 degrees, turn the heat off. You're picking or selecting an outcome. Turn the heat on or turn the heat off. And you're picking your outcome based on the conditions of the house. Is it above 72 degrees or is it below 72 degrees? This is selection. Finally, we have iteration. Iteration is like loops or repeating actions. So in our stoplight example, we talked about a stoplight that will turn green, and then it will turn yellow, and then it will turn red. And then the stoplight will turn green again. Then it will turn yellow, and then it will turn red. And then it will turn green, then yellow, then red, then green, then yellow, then red, and so on and so forth forever. That is an iteration when it turns green, yellow, red, and back to the top and bottom. Okay, code is repeating itself. The actions are happening over and over again. This is iteration.